Question 13. Martin prefers to measure distance in kilometres rather than miles. The following table shows the number of miles and the number of kilometres for each of three distances. So 5 miles is 8 kilometres. That's a conversion that you should know, by the way. 30 is 48. Notice there they're in direct proportion here because that's gone up by times by 6. So is that one. And 42.5 miles is 68 kilometres. Okay, use the data in the table to draw a conversion graph. Now, a conversion graph just means that we plot these things as coordinates. Okay, and the only kind of tricky thing that they've done here is that they've left that off, haven't they? Well, let's try and use this scale down here. So what I mean by that is it goes up to 68, doesn't it? So let's try and make the kilometres go up to the closest multiple of 10. Near to 68, which is 70. So if we do that, we can just try it basically and see if it fits nicely. So remember that each kind of full big square has 10 blocks in it. So if I start at 0, 10, 20, 30, 40, 50, 60, 70. So that's using most of the graph. So that seems a nice scale to use. Okay. And then I'm just going to plot coordinates, and I want to be able to draw a conversion graph, which means I need a straight line basically. So I know one coordinate, 0, 0. If I travel no miles, I've travelled no kilometres either as well, have I? So I've got one coordinate straight away there. I've then got 5, 8, which will be 5 miles to 8 kilometres, which is there. These need to be exact, these coordinates, okay? And the next one is 30 kilometres and 30 miles to 48 kilometres, which is up there. I'm not going to plot the last one because I don't particularly have to try and plot that really. Okay, but, well, I can't either, can I? No, I can't, sorry. 42 and a half and then 68 to be up there somewhere, but I've got 3 points there, so I can just draw those ones. Okay, so if I line these up, these should all fit on my ruler like that. And then I'll get a nice straight conversion graph going through those coordinates like that. Okay, dead easy, 3 marks, that one. Right, the next question for this is over the page, which is a bit of a pain. But the distance between Martin's house and his favourite bicycle shop is 70 miles. Explain how we can use the graph to find this distance in kilometres. Well, what you would want to do here, if it said it was 40 miles, that'd be dead easy. We'd go to 40 miles, we'd go up, we'd put a cross on the conversion line at that point and then just read off how many kilometres it is. But the problem that we've got is that it's 70 miles. Now, 70 miles isn't on here, is it? So can anyone spot what you're going to do? There's different ways of doing this. Basically, you're going to have to use one of these numbers along here and then do something with it to get to 70. I want 70 miles. Okay. What would half of 70 miles be? If that's jogged your memory and you think you know what you're doing, pause the video, carry on. Otherwise, 70 miles, half that will give me 35 miles. Now that is on here because that's there, isn't it? That's 35 miles. So if I convert 35 miles, then I can double that and it will tell me what 70 miles would be. So let's do it that way. So 35 miles will take me up to there. So if I imagine a little cross there, I'm going to read that one off going across this way. And that takes me to around about 56 kilometres. So I'm going to times that by 2, which will give me 112 kilometres. I'm going to write that over the page. Okay. So explain how we can use the graph. Well, what we did was 35 miles equals 56 kilometres. So then 70 miles will be about 112 kilometres.